Hello and welcome to another episode of Modular in a Week. I know I have zoned in on Emily Gillet Mutable Instruments modules, and today is not different than the previous two versions. I'm going to do another version of Mutable Instruments modules. So today I'm going to do the grids. Can't use that word, so we're going to do the GRIS, which means pig in Swedish. And it's a through-hole version with a Arduino Nano module on the back version of the grids. This is quite a simple module. It uses an Arduino Nano. It's not that many parts, but as you can see with all these wires and stuff here, this has given me so much grief. And I don't know, it was the reason for that. There's probably a good reason that I had trouble with this, all coming down to me, my laziness, my unfocusedness, stuff like that. So that's why this video has taken some time to make. However, it's done now. There are new versions of this board coming my way, and with all the errors taken out. This has been a journey of learning. I did two major mistakes that I want to highlight. First thing is, quite early I found an error that these jacks here were all jumbled up, and I did this on the back, routed them all to the correct place on this board, and then I redrew the schematics with that and did some other fine-tuning of the schematics. Then I found there were other errors with this and continued to error check with the new schematics. So an old circuit with a new schematics, that really does put a big stick in the wheel of your troubleshooting. So that is lesson number one. Don't remake the schematics and then troubleshoot old stuff with it. Second one is blaming software when it's obviously hardware. I thought I did something wrong with putting the software onto the Arduino, and did that over and over again, and worked so hard with something called fuses, trying to get those right. But in the end, if I just had stopped and maybe had listened to all the voices on the Discord server, that it was probably something with my reference voltages. It would have gone faster to fix this. When it comes to the reference voltage, it was kind of, there's a small sub module here with a 4040 5-volt regulator that I thought was the problem. That's the negative rail. In the end, it turned out that I had totally effed up the regulator, the normal 5-volt regulator, which was sitting here, and I had messed up the pins, and then I had routed what I thought was 5 volts into V-in on the Arduino and on the 5-volt pin on the Arduino. So there was a misplaced7805 working with the wrong voltage out into both of the pins of the Arduino, which meant that the onboard regulator on the Arduino tried to put out one voltage and this one gave it another voltage. So I ended up, all the trouble was that of course, wrong, way too much power on all the potentiometers, so the voltage in on the Arduino was way too high, which made the knobs not correspond in the correct way, and also frying a few of the pins and the ADCs of the Arduino. So exchanging the Arduino, totally removing the 7805 regulator, and instead changing the whole design to use the regulator on the Arduino, which is cost effective as well, because we already have a module with a regulator on it. Why add another regulator? So that's $1 less in cost for this one. So long story short, it works now. So what is this? This is a topographic drum sequencer. So this is something like a live drummer in your rack. And if you want to have some movement in your drums and not have that static 4 on the floor with a snare drum on every second beat and hi-hat going in 16ths, then this one is really a nice module to have in the rack. There's tons of videos showing how to play with this one, use this one, and of course you should watch those instead of me doing that. I'm just building this, showing how to build this, and those other people make music with it, which I try to do as well, but not on camera and not explaining everything I do. So yeah, these are of course sets of PCBs that you can find in my store, but also because it is Emily Gillet's stuff and she did all her stuff open source. These are also open source. You can download the Gerber files and make as many as you like and do whatever you want with them. They are in the public domain as such. Links to everything in the description for that. Before I go and show you some of the process around this, I'd like to say thank you to my patrons who are amazing, supporting my work, and one of a few ways that you can all support my work is by becoming a Patreon. So thank you everyone who are doing that, and thank you everyone who buys these modules in my store, which is really fun to see that I do make a few modules that are interesting. I'm not saying I did these modules. These are all Emily Gillet. I just made a simpler version, more available to the public, to the general DIY community, I guess. So it's always fun to see that when you send in pictures on the Discord, mostly when you have them up and running and making stuff. Cool. So let's go and see a bit of what we can do to make this. This module, just like the previous two, of course starts with Emily Gillet, Mutable Instruments, open sourcing all of her modules, making it possible for anyone, me, you, anyone, to make their own, either with all her files or, like I did here, make my own PCBs. And if you go into Pichenet's, her GitHub, and then into Urac and Grids, you will find all the information here, the hardware design and the bootloader and the program to put on the Arduino, which we'll go through in a bit. If you want to know more about it, there's tons of videos of this module online, of course. Here's the Grids manual. This one is quite good to have handy. This is a bit about how it works. This is how it works, and this here is the settings menu, which I have on the back side of my front panel. There is a small diagram showing this. I was contemplating putting it on the front, but thought it would be too messy and you're not inside changing this so much. But there's a really short image on the back of the GRIS that you can just jot down on paper if you don't want to print this. But I would recommend having this around. If you want to know how the Mutable Instruments Grids work, there is this URL that you can visit. I'll put links to all the URLs in here in the description of the video, but here you can see what happens when you turn all the different knobs and what happens. In Emily Gillet's GitHub there is no schematics in a PDF format or in a readable format for me, so I found this place, BGR360 GitHub IO, where that has a collection of all the Mutable Instruments schematics in a PDF form. So this is what I used. I used the grids down here. So this is the schematics I used. Then I went into ECEDA and had to redraw this schematics here. So this is the schematics that I am using, and the schematics that is used for the GRIS PCB. It's almost identical. There are a few things. If we look here, there is a bit of things on the 5 volt here, and there's also the LM1117 5 volt regulator down here. Because we have all this on the Arduino Nano, I'm actually just using the VN here, 12 volts straight into VN, using the onboard regulator of the Nano and getting 5 volts out to power the circuit. This is one of the things that gave me lots of grief and destroyed my first module, that I messed this up with another regulator and stuff like that. But so that's the schematics. I want to mention there are other variants, of course, that you can build. I built the GRIS is supposed to be as close to the original as possible, to look and feel as much as the original as possible. TP Carlson or Twig over on my Discord made a version quite a long time ago when we started talking about this. I've been working on this one a long time, just sitting waiting for the right moment. So he's built one. Let's see if there's an image here. There is not. Here we have on the Discord. So this one is made with faders, which actually can be beneficial in many ways and might be a good way of using this, because in a live situation faders are much faster going from 0 to full if you want to do that, and then potentiometers are. So if you prefer faders, good to know that you have this one. Not sure if he's selling PCBs, but yeah, you can send him an email down here. And then there's of course the Nano GRIS, which is, I believe it's kind of similar. I think this one is made in the same way, uses the original schematics to build the PCBs. I think he's using 2 PCBs here. That was one of my goals as well, to just bring it down to just using 1 PCB, again for cost effectiveness. And so mine is a bit more, or a lot more crammed than this one, so bear that in mind. There's other kinds you can buy as well, or get. Then we come to the program in itself. So on PCNet's GitHub, you will find under the make file, you will find the program, and we see here that the MCU name is 328, which means it's basically an Arduino Uno or an Arduino Nano, and in this case we're using the Nano because it's actually so cheap, so there's no reason not to use that. I believe buying a 328 deal or dip package is actually more expensive than buying the PCBs that are Nanos from AliExpress or a place like that. This gave me the next problem, and I did work a lot with a hex file that I got from this page, the GRIS page, and tried to set the fuses of the Arduino Nano, because I thought that this was the reason for the pots not working, when I actually had made a huge mistake with power in the completely wrong way. Anyway, so in the end, I ended up installing the Vagrant development system that Emily has made. So a small virtual machine on your computer that you then go in and you get the whole URAC tree from GitHub. You can use the make command to make the hex files for this. So that's what I ended up doing, and I put that hex file, a link to that, in the description as well. So we have that, and I know that one is working, and that is straight from Emily Gillet's page. So that should be nothing strange about it. So now we have a hex file. And that was the second or third or fourth or whatever problem in the order that I've had with this one. How to put the hex file onto the Arduino Nano, because you can't just load the hex file into the Arduino IDE and put that onto the Nano. And yeah, I read quite a lot of forum threads about this. Didn't come up with anything, but then someone... so I tried AVR Dude and got that to working, but it was quite a tricky mess and lots of parameters that needed to be correct. But then someone showed me AVR Dudes. So this is a GUI for AVR Dude. And this one is really simple to work with, and I will show you how to put the hex file onto your Arduino. Again, one of the many good places to talk about the GRIS module is my Discord server. There's also a link for that in the description. Come and join the discussion. I've asked a ton of stupid questions here, and quite a lot about the fuses. That has been a big source of my pain that in the end didn't matter at all. The files for this project, if you want to make them yourself, the Gerber files for the PCB and panel, you can find on my GitHub page, also a link in the description. Here's also the schematics, and I will also put the hex file here so you can use that for this project. And by the time this video comes out, I hopefully will have the PCB panels in my store as well, so you can buy just one of these for a reasonable price, and hopefully also some components. Not sure about the Thonky-Cons. I am unable to get a hold of the seller on Kingpoo to get me new Thonky-Cons, unfortunately. So yeah, that is the journey in software for this module. Let's go through and look a bit on how we put it together and how it works in practice. Component-wise, there's no special components as such. There are the usual resistors and capacitors. There are 2 transistors. There's a 595 shift register, and that's basically it. And then of course you need to source an Arduino somewhere. Not this one. This one is totally broken after my endeavors in trying to get this to work. So this is the one I fried. But the cheapest way to get these is on AliExpress or eBay or a place like that. They are about $2 or $3 for one of these. They're good for a lot of these different kinds of projects. The thing that costs money in this project is there is 7 pots, so that's quite a lot of money there, and then there's 14 jacks. I'm having trouble sourcing Thonkicons. I can get them from Thonk, of course, but not directly from King Poo. So that's why I had to revert back to the old style that I used before. These are really cheap though, so that is good. If you choose to buy the kit from me, then these are not that expensive. I think this stands for half the cost, at least, of the kit. And then we have the trouble with the MCP 6002, which is the op-amp that Emily uses, and they are really hard to find nowadays in deal packages, and when the ones I found are really expensive. They are between half and $1 for one piece. So that's actually just as expensive as the pots. So I've chosen to do this in 2 different ways. If you choose to buy my kits, you can buy them with MCP 6002 in SMD format, and you get one of these along with it. So 3 SMD to through-hole converters. So you just solder these together, and then you have 3 MCP 6002 for a fraction of the price. But then you need to do some SMD soldering, which can be daunting for some. The other option is to use these LM358, which costs just the same as these, also a fraction of the cost from a MCP 6002. Not as good, of course, but I've tried both my builds of these, and they work with the 6002, so I don't think that should be a problem. But I'll also sell the kits without op-amps if you have MCP 6002 lying around. There is a Zener diode in the kit that is in the Grids original. There is an LM4040, I believe 5-volt Zener diode to voltage regulate to 5 volts, or minus 5 volts actually. This one is the 1N4733, so 5.1 volts, so not as accurate as the 4040, but again, cost-wise, this is much cheaper, and also 4040s are hard to find in through-hole, so that's also one of these things that in one of my builds, let me get that one. In this one, let's zoom in there. This is actually a SMD 4040 on one of these boards, just like these, soldered onto there, and just using those 2 pins and connected like that. So it works. It's not very beautiful, but neither is anything in this one. Yeah, it's these decisions that I have to make when doing the kits in a shipocalypse world, I guess. And then we have the panel and the PCB. Panel, nothing special really. I'm trying to stay as close to the original as possible. I have these cheap pots in kind of the correct color scheme on this one. Yeah, nothing special about the panel, except maybe that on the back side there is that chart telling you all the different settings that you can get into. If you press and hold the tap button for 1 second, you get into settings, and then this one is a very rudimentary instruction to that. More of that in the manual, as I showed before. The PCB, nothing special either. Of course, this is a really crammed up PCB, so you have on this side, you have all the controls for the front panel, and on the back side is the Arduino, space for the Arduino, and then all the other components, which in the end looks like this without the special traces there. I'm putting out a build video for this as well, of course. If you want to build it and build along with me, you can do that. Otherwise, it's quite straightforward. If you just take out either the iBoom, which I'm starting to create for my kits, and or also the schematics works either way. Now we've come to the firmware, and to get the firmware onto the Arduino Nano, the firmware comes as a hex file, and just as I showed you in previous episodes how to put the hex file onto an STM32, you need a program specific for Arduino in this case to put the hex file onto the Arduino. I am unsure if you can use the Arduino IDE. I don't think you can. That's for sketch files. So there is a command called AVRDude that is a command line tool to put hex files onto 80 megas AVR chips. It's quite complicated, and when I tried to do this, I had some trouble getting that to work, and there was a lot of workarounds to get AVRDude to work. Then someone on my Discord told me about AVRDudes, which is a GUI for AVRDude. And this is much, much simpler to work with. Use the link in the description and you will find this page, or just do a Google search, of course works as well. Download the setup file or the zip file if you prefer that. I'm not going to show you how to install this because I already have installed this, but usually it's just next, and you are done. So no rocket science there. And once installed and you open the program, you will get this window here. We will start to need to choose the programmer. In this case, you have Arduino as an ISP. We're not going to use that because we have an Arduino directly connected to our computer via the USB port. So we're going to connect that. We are going to select our COM port. It's not here right now because I haven't connected my Arduino. The MCU, we are going to go down the list. There is a lot of MCUs here, so 80 mega 328P I believe is the one we're going to use, which is in the Nano. If we connect our Nano, we should now have a COM6, which is our Arduino port in this case. And depending on when and where you bought your Nano, it is either the old bootloader or the new bootloader. And depending on which bootloader you have, if you have the new bootloader, you will need to have baud rate 115200. And if you have the old bootloader, you need to have 57600. So it's not super important. You won't destroy anything if you have the wrong one, but it won't work. I'll show you how it won't work, so you can just see that if you get this error, you can just switch this baud rate. Then we need the flash file, and I have that here. You can find that on my GitHub. If you go there, you can download it. It's all ready to go. We don't need to do anything else here. We just press the program, and if we have the correct baud rate, it should be writing and reading and verifying and done. So in this case I had an old bootloader then. So let's just take 115200. Let's do this again, and this time this will happen because we have the wrong baud rate. So programmer is not responding, not in sync, and then you just press stop and you just change to the correct baud rate. No, that was the wrong one. No, that was the correct one. And you program it and it will work. So no risk of destroying the Arduino if you have the wrong baud rate. But it won't work, so good to know. And once that is done, we take the Nano out and we put it into our GRIS. And it should be with the USB port facing downwards towards that op-amp. So GRIS that way, and the USB port facing downwards, and that. And now we just put it in the rack and start playing. And with that, we have our third Mutable Instruments module in our rack. We have it here, and along with the braids, throughhole, and the peaks module, we're up to 3. I am going to make one more. I have the prototype here, and you see it's a prototype because it looks like this in the back. I'm gonna make a branches clone as well, because, well, while we're at it, it also uses an AT-Mega 328, not the original, but this one does. More about that in the next video. This one is of course also the prototype, or the first variant, so there's always a bit of wiring in the back before I get down to the final piece over there. I'm going to make more drum sequencers. They are very good to have in the rack. This one is more for an organic feel, but I like to have a few other more static feeling drum machines as well, for making techno, dance music, that kind of stuff. But before that, one more module from Mutable Instruments, branches, and yeah, we'll continue this journey of filling this one with new modules. Now the journey is replacing modules, but yeah, still the modular journey continues. So if you haven't already, subscribe so you know when new modules come, and if you want to build this one, you can. It's not that hard to do on breadboard as well. If you want to do that, order the kit or the PCB, or just download the Gerber files and do it all yourself. And I will see you in the next episode. Take care. Bye.